Okay, so this is the first problem of the contest, chess for three. It says that three people are playing chess together, and in every game, two people play against each other. The winner will win, the winner will win 2 points, and the loser will get 0 points. And in case if there is a draw, then both of the players will get one point each. And they have told that the same pair of players might play any number of games, and it is also possible that the pair of players does not play any game. And we have been told the scores of the three players P1, P2, P3, and we have been told that P1 is less than equal to P2, which is less than equal to P3. And we have to tell what is the maximum number of draws which could have happened during the game. And in case if there is no such possible combination of uh, the games such that the three players could have got P1, P2, and P3 number of points. In that case, we have to print -1. So let me just write it here as well. In brief, the problem says that there are three players. Let's say the players are player one, player two, and player three. Let's say these are the three players. They played some games with each other, and it is completely possible that the player one and player two played 10 games with each other, and player one and player three might have played only two games with each other, and maybe player two and player three did not play with each other. So this kind of thing is possible. And let's say if there are two players, player one and player two, who play with each other, and player one wins the game, and player two lost. Then player one will get 2 points for winning. Player two will not get any points because he lost. And in case if it was a draw, if both of the uh, players had got a draw with each other, then both of them would have got one point. And we have to tell, like in the problem, we will be given three integers P1, P2, P3. Let me denote these as capital P when I'm talking about players. And these P1, P2, P3 are the points of the three players after playing some games with each other. And we have to tell how many, like what is the maximum number of draws which could have happened during this uh, tournament, like not a tournament, but the games which they played with each other. What is the maximum number of draws which could have happened? And in case if it is not possible that the three players would have got P1, P2, P3 number of points at the end, then you will just have to print -1, I think. Yep, you will have to print -1 if it is not possible. Let me give you one example that let's say if the problem said P1 is 1, P2 is 0, and P3 is 0. So there is no way that this kind of situation could have happened because in any game, either the winner gets 2 points or both the people get one points. Right. Okay, so first of all, confirm whether the problem is clear or not. Tell me about it in chat. Is there anybody who could not understand the problem? Okay, very well. The solution here is like pretty straightforward. The very first thing, which should be very obvious here, is whenever two players play a game, either the winner is getting 2 points or both of them are getting +1 points. And obviously, the initial scores of the three players will be 0 0 0. So, like eventually, the sum of the points of the three players will definitely be even because +2 will be increased. Like it might be increased for this guy or it might be increased by 1 for two people. But eventually, the total score for the three players would have increased by 2 for every game. So this thing must be even. In case if the sum of three, like in case if sum of P1, P2, and P3 is odd, then you can straight away print -1 if this is odd. Right. Now talking about the case if it is even. Okay, so let me repeat once. What I said here is initially the three players P1, P2, and P3 are having the score 0. And whenever two players play a game, it does not really matter whether the player 1 won or player 2 won or it was a draw. In any case, the like either a player will get a +2 in his points or both the players will get +1 points. So eventually, to like if you look at the score of the three people, then that sum is gonna be increased by 2 only. है ना? Either one of the people, like one of the scores will be increased by 2 or two of the scores will be increased by +1 and +1. So eventually the total score will increase by 2. So the total sum should always remain even. In case if the P1, P2, and P3, which have been given to you, have the sum odd, then you can directly print -1. Now talking about the case when it is even. One thing which you can try to do is just try to prove that in case if P1, P2, and P3 is is even, then it would always be possible to have this situation. And this is pretty obvious because let's say if P1 plus P2 plus P3 is even, there can be like only a few scenarios. Maybe P1, P2, P3 all can be even. In that case, it is pretty obvious that P1, like the player one would have won P1 by 2 number of times and so on. It is always possible to have that situation. In case if P1 and P2 are odd and P3 is even, again that is gonna be possible. Like P1, P2 can have a draw and in that way. Like I'm not explaining completely because it is just overkilling the A problem. Generally, people don't prove the A problem. So I just gave you some hint that how you can actually prove it mathematically that if P1 plus P2 plus P3 is even, then it would always be possible to have this situation. So the answer will definitely not be -1. And my idea here was, you know that P1, P2, P3 are in this way. In case if P3 is greater than P1 plus P2, then the maximum number of draws you can have is actually equal to this much only. Like the only possibility is that P3 might have, let's say if P3 is equal to 7 and P1 and P2 are equal to maybe 2 and 2, actually 2 and 3, because the sum should be even, then it is completely possible that the player 3 got 2 draws with player 1 and 3 draws with player 3, sorry, player 2. And for the remaining points, he would have won against someone, right? So our answer in this case should be equal to P1 plus P2 in case if P1 plus P2 is less than P3. And in the case when P3 is less than or equal to P1 plus P2, I'm not telling you about the proof here, but actually at the end of the day, our answer comes up to be P1 plus P2 plus P3 by 2. And the idea here is like this is a very common thing. Um, this is kind of a problem that you are having three integers P1, P2, P3, and you can just choose any two integers and decrease their values by 1 1. You can relate it with that problem where in case if the maximum element is less than the sum of all the other elements, then you are always able to convert all the elements to 0 when the sum of the elements is even. And in case if it does not make sense, maybe if you are looking at something like this for the very first time, then you can just refer to the editorial for a mathematical proof. Right now we are just willing to discuss about the intuitions, and I'm not willing to cover the standard stuff. So should we move on, or does anybody have any doubt for this problem? Can you please explain why uh, 2 can't do? Can you please explain why 2, why can't, like what are you asking about? Please everyone just mute.
हम इसमें मिनिमम्स क्यों नहीं ले सकते थे कि अगर हम दो प्लेयर्स का आपस में मिनिमम कर लें कि इतने ड्रॉज हो सकते हैं?
Yeah, like see, uh, I think that you are asking for this situation that if P3 is less than equal to P1 plus P2, then why is my answer coming up to be like this? Are you asking this now?
नहीं, मैं ये पूछना चाह रहा हूँ कि अगर हम इस प्रॉब्लम को अलग ऐसे सोचते हैं कि अगर हम दो प्लेयर्स आपस में गेम्स खेल रहे हैं तो मिनिमम वही नंबर हो सकता है कि जो छोटा नंबर हो वही, मतलब कि वो हो सकते हैं कि इतने ड्रॉ मैचेस हो सकते हैं।
Yeah, like if there were only two people, maybe like 7 and 3, if there were only two people, then
हाँ
it
तो,
would be equal to this.
हाँ मैं यही कहना चाह रहा था, तो हम
Yeah.
ऐसे नहीं सोच सकते थे इस प्रॉब्लम में।
Yeah, but like when there are three people, maybe something like 7, 3, and 2. So what should be your answer
आई गेस
with your
6।
logic? Huh?
6।
6. Actually, when you will try to figure it out, six will never be possible here. Because the thing is, this guy, seven, like the one who won 7 games, can have three draws with this and two draws with him. है ना? If you like have a game where both of these people had a draw with each other, then obviously you will have less number of draws. The maximum number of draws you will be able to get is gonna be when this guy is having uh, draws with all these people. So like all the points these two got were by draws. Try to think about the case where you will get six draws. It will never happen.
ओह, थैंक यू।
Did you get it? Like, did you get why your answer is incorrect?
हाँ, समवॉट।
Yeah, like just take the case that you are thinking that the answer can be six. If there are six draws, obviously along with this guy, there should have been other people having at least 6 points now. If the other people are not even having total 6 points, then how could there be six draws? One person cannot have a draw with himself.
हाँ, आई गॉट इट, थैंक यू।
Okay. Okay, so somebody is asking me to try run for the case 3, 4, 5. Let me just have a quick dry run. Um, just 1 minute. Yeah. So for the case like 3, 4, 5, you can just try to have draws within the people having the maximum values, and like 3, 3, 4, you got one draw. Now pick up these two. You got 3, 2, 3. Then pick up these two. 2, 2, 2. You have got three draws till now. And among these as well, just pick up these two. 1, 1, 2. Then pick up these two. You got 1, 0, 1, and then pick up these two. So like 1, 2, 3, 4, 5, and then 6. We got six draws. Pick two minimums. No, no, no. Pick two maximums. Pick the two maximums and decrease by one. 1, 1, 2 वाले केस के लिए गलत आ रहा है. Here you can just have a draw between these two people, and then for 0, 1, 1 you can have a draw within these two people. So this is how you can have two draws.
हेलो। अ, हाँ भैया, मैंने ना प्रायोरिटी क्यू से इम्प्लीमेंट किया था।
Hmm.
हाँ, तो उसमें मैंने बेसिकली यही करा है कि मैंने सबको पहले तो क्यू में डाला। उसके
हाँ.
बाद मैंने मैक्सिमम ले लिया, उसको पॉप करा। मतलब
Hmm.
जो टॉप एलिमेंट है उसको पॉप करा, फिर
हाँ.
जो सेकंड मैक्सिमम है उसको पॉप करा, दोनों को 1 से रिड्यूस करके, आंसर
हाँ.
को प्लस प्लस करके, और फिर चेक करा कि अगर वो जीरो है तो मैंने मतलब उनको पुश बैक नहीं कर रहा वापस क्यू में, अगर वो जीरो नहीं है तो मैं उनको पुश कर दे रहा हूँ वापस।
हाँ.
तो इसके उस मतलब सेम इम्प्लीमेंटेशन किया है, बट मेरा ना ये केस में फट रहा है, 1, 1, 2 वाले में पता नहीं क्यों फट रहा है।
हाँ, तो
माइनस।
like logic, तो you can just see that if you just implement it with priority queues, the answer will still come correct. The mistake you would have done is in implementation probably. Like the logic you are saying is correct, but you would have probably made a mistake in implementation. Okay, so anyone else having any doubts?
सर हम इसमें मिनिमम को रख के क्यों नहीं कर सकते इसमें?
It will not really be good. Just take the case 7, 3, 2. If you take the minimum two people, then you are just wasting two draws. Like you could have got a You could have just got two games of this guy with like one with this and one with this, and you could have got two draws in that case. But if you just make these two people have games with each other, then their values will be reduced. Both of them will have got their values reduced by 1 1, and the number of draws you would have got is just one. I hope that it made
नहीं
sense.
मेरी अप्रोच थोड़ी सी अलग थी जो मैं चला यूज कर रहा था। जैसे 3 4 5 वाला ही केस ले लेते हैं।
3 4 5 wala case, okay.
हाँ
Yeah,
तो मैंने क्या
let me
करा
just show
था।
you for 3 4 5 also. If you
हाँ,
just think that I will take the minimum two people every
नहीं
time for this three to
मैं
five,
थोड़ा सा अलग सोच रहा था
mm,
कि जैसे
like
3 वाला है, 3 को
हाँ
0 करके 5 में से 3 का जो अपर बाउंड डिवाइड बाय 2 मतलब +1 डिवाइड बाय 2 माइनस कर रहा था और 4 में से 3/2 माइनस कर रहा था। ऐसे करके बाद में मैं 1 1 1 माइनस करने लगा था दो जनों के बीच में बिठा के।
it might have worked, like it might have worked, you might have done something different. Baki, you don't really need to do all this. Like you don't need to use parity queue or just make it this complicated. You just see that the solution could have been this simple. Just NFL's line wala code.
नहीं वो मैंने नॉर्मल बिना किसी चीज के यूज करे करा था क्योंकि सॉर्टेड तो हमें मिल ही रखे थे ना।
हाँ sorted तो हाँ.
तो मैं पहले वाले को एलिमिनेट कर रहा था पूरा, बाद में सिर्फ दो जने बचे थे तो मैं उनके हिसाब से कर रहा था कि 1 1 माइनस करता चलूंगा मैं। और
Yeah,
अगर लास्ट में मेरे को कोई
maybe
ग्रेटर
we
देन
can
50।
discuss about your approach after the session. Like it is, I think, just wasting everyone's time because it's not even the best approach here.
ओके ओके।
So yeah, would it be fine now?
या श्योर।
Okay, okay. So now, uh, like if anybody is having some doubt related to my approach, then please ask, else we can move on to the code. I think that today we just spent too much time on the A problem. Okay, let's go to the code then. Uh, for the code part, ignore this, and this part. Like this is just my template, a very small template. The main thing which you need to see is this part only, written inside this solve function. I took all the three elements as inputs, and during the contest, I had not read that the input will be sorted, so I just sorted it because I did not know about it during the contest. And after that, I'm having this condition that if the sum of the three elements is odd, then I have to print -1. And like otherwise, I will just check if the smaller two elements are having their sum less than the largest element, then in that case, I will just print the sum of the two smallest elements because I cannot get a better answer in this case. And in case if this condition is not true, it means that the sum of the smaller two elements will be greater than or equal to the largest element. Then the answer will come up to be the sum of these three elements by 2. Um, because if this is the sum of the three elements, the sum of all the points, and you know that in every game there were 2 points to be added in any player. So obviously this many games will be played in total. So this is the maximum number of draws which could have happened. Shall we move on to the next problem? Okay, great. So let's see the B problem. Cat, fox, and lonely array. The problem says that we define the loneliness of A, which is, I think, yeah, A is an array. So we define its loneliness as the smallest positive integer k, such that for any two positive integers I and j, the following condition holds, that is the sum of, the bitwise OR of the k elements starting from index I should be equal to the bitwise OR of the k elements starting from index j. And they have just defined that this is the bitwise OR operator, and it is for every k. Okay, so they have just told about it in like simpler words also, that for every k consecutive elements, their bitwise OR should be the same, and uh, like the loneliness of A will be equal to n in case like it would always be less than or equal to n. They have just said that it is always defined. There will be no case where the loneliness is not defined. And like it's obvious that if you're talking about k equal to n, then the only possible value of I and j will be equal to 0. So this thing will definitely hold and our answer will be equal to n. We want to find out the smallest possible value, and that's it. So we will just have to print it. Let me just write it here as well. So the problem is you will be given an array of n elements, and the condition is like you will be given an array of n elements and an integer k, and sorry, you will not be given the integer k. You will have to print, you will have to find out the smallest possible integer k, such that for every subarray of length k, like this can be a subarray of length k, then this can be a subarray of length k, and similarly the next subarray of length k, and another subarray of length k, and so on. For all the subarrays of length k, their bitwise OR should be equal to, like should be equal to each other, should be equal to each other. Okay, so we have to find this integer k. Is the problem clear, or does anybody have any doubt? Hmm? Okay, great. So, yeah, is it true that if k is an answer, then k to n all potential answers? I think yes. Yeah, all of them should be the answers. First of all, let's discuss the problem and then we will look for the proof. I think that just looking at my proof will explain you the reason, like the doubt which he had asked should also be cleared, I think. So, like the approach which I had in during the contest, okay, some people are talking about binary search. Actually, binary search will work, I think. I heard that somebody else as well solved the problem with binary search. They were searching for the value of k. In my case, what I did is I noticed one thing. Let's say if the elements of the array are um, yeah 20402. Let's say that the elements of the array are 20402. Then since we want that bitwise OR of all subarrays of length k should be equal. है You want that the bitwise OR of all the elements of length k should be equal. And you know one thing, like if there is an element like 4, which is 100 in binary, like it is having this one value bit set. है So whenever, like in any subarray in which this 4 comes, this bit will be set in the bitwise OR. So it means that all the subarrays of length k should have this bit set. Does it make sense? Just tell me in chat. Does this thing make sense? Let me just repeat it once again also. What I said is, like the observation which I am talking about is, since you want that the bitwise OR of all the all the subarrays of length k should be equal. So if you talk about any element like 4, which is 100 in bitwise, like in binary representation, which is having this bit set. So in all the subarrays where this guy comes, obviously it will come in at least one of the subarrays, and in whichever subarray it comes, the bitwise OR at the end, the bitwise OR will definitely have this bit set. So can I say that I want to find out a length k such that all the subarrays of length k should have this bit set in itself for sure. Similarly, for this 2 as well, which is having a bit set here, so like it is 010 in binary. Since it is having a 1 here, it means that this like the bitwise or like the bitwise OR of all the subarrays of length k should have these bits set in themselves. It will be true for each and every element in the array. So eventually, my problem has now become find the smallest value of k such that uh, it's like the okay, I can just write it as such that all the subarrays with length k will have the bitwise OR of its elements equal to um, bitwise OR of all elements of the array. Bitwise OR of all elements of the array. Does it make sense? I think I took a long time in writing it. So guys, please tell me in yes or no. Does it make sense? And now it is something obvious that if all the subarrays of length 4 are having their bitwise OR equal to the bitwise OR of the complete array, then for all the subarrays with length 5 will definitely have it, है ना? Because for each and every subarray of length 5, it's like some portion of that subarray is in itself like completing the condition. So here applying binary search on answer basically for the value of k makes sense. This thing will work. I hope that your doubt is also resolved. Somebody asked this thing on doubt, like in the chat, that will this work? Okay, so somebody is saying TLE aa gaya. You must have done some mistake, I think, because I have not like I did not do it with binary search, but I heard that somebody else did with binary search and it worked for me. And mine was actually worse than this. In my approach, what I did is not worse, but it is like equivalent, somewhat equivalent. My approach was that if you are having an array like 20402 maybe, or it was, yeah, this kind of an array, like for the bit with significance as like with the weight 2 raised to the power 2, basically the bit with index 2, if it is coming at this place, I can just find out where is it coming in the complete array, all the places where it has been coming, and I just assume that on the left element of the first element and for the right hand side of the last element, just I assume that at these places, let's say if this bit is coming, so to make sure that this bit is present in all the sub like all the subarrays of length k, I must have k being at least equal to 3, right? Because these are at a distance of 3 and these are at distances of 3. So my length of subarray should be at least equal to k, and I was having this kind of conditions. Baki, like I think that the other solution of just searching for just applying binary search on k is a lot simpler. I think you can very easily just apply binary search on the answer and it will be like very simple problem then. So guys, does anybody have any doubt? Okay, can you do try run for 20402? Yeah, like not for the binary search. I think that I will do a try run for my approach. Okay, so in my approach, for the bit with index 0, it is not set in any of the cases. Like you don't see any odd number here. So I didn't do anything. For j equal to 1, the uh, bit of the index 1, which will be having the weight 2 raised to the power j, are set here and here. So since these are coming up at a distance of 4 from each other, the like value of k must be at least 4, है ना? So that every subarray of length 4 will be having the bit set in itself. And just make sure that this and this cases are also covered. And that's what I did. Someone is knocking the door, so I will come in just 1 minute. Just 1 minute, guys. Okay, I'm back. Okay, so here for j equal to 1, we see that this is the farthest distance, which is equal to 4 here. So your value of k should be at least 4. Any like answer maybe. Initially, you could have declared your answer to be 1, or yeah, the answer will definitely be at least 1. Na? And after this, you got to see that uh, this j equal to 1 value bit is coming up at a distance of 4 from each other. So you initialize the answer with 4 now. And after that, you would have looked up for the bit for j equal to 2, which is coming up only here. And it's not coming up here or here. And you see, you want all these subarrays. Like even this kind of a subarray should not exist. And this kind of a subarray should not exist. So the value of k should be at least equal to some amount such that the first subarray should be like this, at least this long, and the last subarray should be at least this long. This is why we are considering the first and the last elements outside the array. So you see that this is 3 and this is 3, the maximum is 3, and like answer is already 4, so it would not be updated. And if you talk about any other bit, like as we skip for j equal to 1, we will skip for all the bits like j equal to 3 and for everyone, because the bit is not coming up in the array itself. I hope that it does make sense now. You still might have to think a little bit on your own after the session, but this is now doable for sure, I believe. Does anybody have any doubt regarding my approach or regarding this binary search? How do we make sure that the middle element bit middle elements bits is set? Are you talking about this? Sorry, this. Hariom, are you willing to ask for this? That how will you make sure that the middle element? See, we want that this kind of an array should not exist because this is not good. This is why we have been saying that the value of k should be at least equal to this, so that every subarray will have this. Does this answer your query, or do you have some other query? Hariom? Okay, great. Anyone
have a
else
doubt.
have? Yes.
So what I did was I calculated the prefix or of every element
Prefix
and
or
prefix or prefix sort.
No, prefix sort does not make any sense. See,
So, okay.
if you are having elements as 1, 2, 4, and you want to find out the prefix, like the or of this subarray, and you say that I will take the prefix or till here and I will subtract this. This might give you correct, like this will never give you correct answer.
No,
Indeed,
so
in total.
I did it in 20 into n complex. Like I did it for it was a 2D array, 2D DP array. So basically, I like for example, like we do for prefix and, right?
Hmm.
Like we check how many ones and how many zeros are there, and if for example between any two elements, for example, for a particular bit, if there are more than one
Okay,
number
I
of
got it.
ones, so it'll
Yes, so you're just like you will just keep track of the number of ones and the number of like the number of ones which are coming till here and the number of ones which are coming till here. You
yes,
will
for a
subtract
specific
it.
bit, and then I did for all the bits.
Yeah, you can do it in that way.
So,
Uh,
but what the problem was that then I had a binary search, and then I
hmm.
did with binary search, and I did this approach. So it was around login into 20 into n, and that was a TLE. So
Let me check the constraints. 1e5 into 20 into log of n, which log of n here would be less than 20. So like 4e7, it should work actually. Like theoretically, we see that it should work. And yeah, I think that it can be implemented unless you would have used something, uh, unless you are having a lot of constant factor, it will work.
okay,
Uh, okay, so like I can look at your code after the class, maybe after the session.
okay.
Let me look at other stuff. How to make checker function and big open with sliding windows. This is a standard thing. You will just have like initially you will have this as the window of size k. Then you will have this as the window, and then you will have this as the window, and so on. So every time, what you can do is just keep an array of size 30. You will So, okay, sorry. The elements are till 2 raised to the power 20. So you will have an array of size 20. And let's say you encountered 7. So 7 is nothing but 111 in binary form. So you will go to that array and at the indices 0, 1, and 2, you will increment the values by 111. And when you are removing the value, let's say you are removing the value 8 from the sliding window. So 8 is nothing but 100, 1000. Yeah, 1000. So you will go to the index 3 and you will subtract 1 from there. You will do something like this, and at the end, for checking, you will just have to go through this array and check the places where you are getting at least one, at least one occurrence of 1. And uh, like if you know that the bit 1 is coming up 3 times and the bit 2 is coming up maybe 1 time. So you know that the bitwise OR will look something like this, and you can just compare it with the bitwise OR of the complete array, right?
भैया मीन्स कि पहले सबका बाइनरी में कन्वर्ट करेंगे और उसके बाद एक एरे में मतलब भरते जाएंगे प्लस प्लस करते टाइम
Yep.
और फिर जिस एलिमेंट को हटा रहे हैं उसका माइनस माइनस करेंगे मतलब तो
Yeah.
अगर हाँ अगर वो एक भी एग्जिस्ट करता है तो ठीक है मतलब वो बिट काउंट होगी
Hmm.
हाँ हाँ ठीक है समझ लो
Okay. Okay. So let's look at the code. By the way, the binary search approach will be very simple. Mine might not look that simple uh, to some of you. So here I have been taking the inputs first, and after taking the inputs, I'm going on for each and every bit. And during the contest, I again messed up here. It should have been 20, but I just read this as 2 raised to the power 30. So like I ran the loop till 30, but it should have been till 20. And in every iteration, I'm just finding out the indices wherever this bit is set. This is the way you can just check if the jth bit is set in a number or not. and then I have been finding out the maximum difference between any two consecutive elements wherever the element has been occurring. And in case if the bit, like in case if the bit does not come even once, then the value of last would have been remaining -1. This is something specific to my implementation. So this is how I am checking that in case if the bit is coming up in at least one of the elements, then I will update my answer. Otherwise, there is no need to do it. Like there is no need to do anything. And at the end, I'm just printing my answer. Okay, so shall we move on? Yes or no? Guys, write in chat. Yes or no? Does anybody?
भैया वो ऑटो सॉल्व एंड क्या होता है वो ऊपर? हाँ,
This is a way of declaring functions. Just search about lambda functions on internet. This is a very good thing. You should definitely explore it. If you code in C++, you definitely need to learn about it.
ओके, ठीक.
Yeah, just search about lambda functions after the class. This is very similar to the functions which we declare globally, but the thing is we are declaring the functions inside a function. So the benefit is if there were some variables which I had declared at this place, then I could directly access it inside this function. It will save you from the problem which we generally have, that you go to the top of the file, you create some global variables, then you access those global variables inside the other functions. And we a lot of times have, we just mess up a lot of times. So it just saves you from that most of the times. It's like callback in JS, I think. Not callback in JS. Like JS also has lambda functions. You might have heard about anonymous functions or function expression. This is very similar to that. Okay, let's look at the C problem. We are getting late. The C problem, cat, fox, and double maximum. This problem says that we have been given an integer array of n elements, which is even, and the array is a permutation of first n elements. The score for another permutation q of length n is the number of local maximums in the array of length n, where ai is equal to pi plus qi. So it says that we have been given an array p of length n, which is nothing but a permutation of the first n natural numbers. Like first n natural numbers can can occur in any order. Everyone will occur at least exactly once. And the score for a permutation q of n elements is equal to, like for finding out the score of permutation q, what you will do is, first of all, you will create an array A, where for every I, ai is equal to pi plus qi. Then the score of this permutation q will be equal to the number of local maximas in array A. For those who don't know about local maximas, obviously this just that term local maxima is a bit ambiguous for the corner elements. So they have actually well defined it. If for any I, ai is greater than ai minus 1 and ai is greater than ai plus 1, then this point I will be considered as a local maxima. The total number of local maximas in the array, that will be the score of the permutation q. So let me take one example from the problem itself. 1, 2, 3, 4. If the permutation is 1, 2, 3, 4 and 2, 4, 1, 3, this is p, this is q, and obviously n is equal to 4 here. So here array A is coming up to be 3, 6, 4, 7. It is nothing but the sum of these elements. Here you see this guy 6 is a local maxima because it is greater than both the elements on the left and right. And there is no other local maxima in the array. And one more thing, like we don't check this for every I, but we check it for I greater than 1, and maybe just you can just say it as I greater than 1 and less than n. So it will not check for the corner elements, but only for those elements which are having one element on the left and one element on the right. Only for those elements we will check whether it is a local maximum or not, and we will decide on this basis. So is the problem clear? We just have to print any permutation queue where the score is maximized. Okay, very well. So one intuition which I had instantly after reading the problem was that since the first element and the last element cannot be the local maximas, and for the other elements, if you say that this is a local maxima, this guy, then you know that it is greater than both the elements on the left and right, which means that this guy cannot be a local maxima. So this guy can become, again, like since this guy is greater than both the people on the left and right, the next guy cannot become. And it means that alternative elements can become local maxima. So out of the n elements, first of all, two elements are already removed. They cannot become the local maxima. And out of the remaining people, only half of them can become the local maxima. So this is the maximum number of local maximas you can have. Does it make sense? Maximum possible score. And since this is a C problem, it is bound to be easy. So we like this looks intuitive that we should think whether it will always be possible to have this score or not. Can we somehow always have the score? Let me take a random permutation. 1, 2, 4, 5, 7. 1, 2, 4, 5, 7, 6, 8, 3. 6, 8, 3. Okay, I can actually have it in this one. Okay, so if we have a permutation like this, um, you know, either like according to what we have been thinking right now, either we can have these three as the local maximas, or we can have these three as the local maximas, right? Either you can have these three coming up as the local maximum together, or you can have these three coming up as the local maximum together. So what do you think? Like since 8 is the maximum guy in the array, can yeah, like the person coming up here might be able to become a local maximum, but in general, since you want to have the elements as the local maximas, like to me it made sense that first of all I should think about these three elements where the maximum element in the of the array is coming up, है ना? Wherever the maximum element of the array is coming up, I would like to try for those elements to become the local maxima. And since I was just doing some guesswork at this place, I wanted to make it as uncomfortable as possible. So I just changed the permutation a little bit. Maybe let's have um, it in this way. So what you can see is if I'm deciding that let's pick up the three elements wherever I find the largest element, then in the worst case, what can happen with me is the smallest elements might be paired up with them. है ना? So is it possible to have like the score equal to 3 in this permutation? If I can somehow choose some permutation Q such that I'm having 3 as the score, then my approach will be pretty much done there. है ना? It would be pretty much done. So let's see. In the permutation Q, I can have an 8 coming up here. So that 8 plus 1 becomes 9. है ना? Since I want these people to be local maximas, I would try to give them as big values as possible. And since I wanna make sure that this 1 plus the QI should be greater than both the other people, so I would like to give the smallest value, the biggest value from the array Q. Similarly, for this 2, I would like to give it the second best value, which is 7. After this, I have only one value left for the candidate. So I will give it the next best value. Now, I think that this looks intuitive. When you look at the problem and if you have to manually solve it, you would try to think of something similar, right? After this, since I don't want to make things worse for me, I will not give 7 the value 5. I will not place a value 5 at this position, because if I do so, in that case, the 7 plus 5 will become 12 and it will be greater than this 1 plus 8. Instead, I would try to give it as small value as possible. I would try to give it a value 1, the second biggest value, I'm giving 2 here, 3 here, 4 here, 5 here, something like this, right? And indeed, there is one more thing which I had in mind, that I would like to give, since I had placed 8, 7, and 6, I placed the next value at this position. Because I know that its neighbor is not one of the ones which I want to have as the local maxima. So it would be good for me to just waste this 5 at a position so that things doesn't not become worse for me. After this, I have to place 1, 2, 3, and 4 as well in the array. So I would like to place 4 here, sorry, 5 here. Oh, I have placed 5, so I have to place 4. I will place 4 here, and then 3 here, 2 here, and 1 here. I will place in this way, so that the array becomes, see, array A becomes 9, 8, 9, 8, 9, 8, 14, and 7. It is becoming like this. And you see that this guy, and this guy have managed to become the largest elements of the like the local maximas. Okay, guys, does it make sense? Like right now, since the problem is constructive, you should not be really thinking about the coding stuff. The main stuff, like the main focus of yours right now, should be at logic. That let's say if this was being given to you and you were being asked to find out an array Q manually. Okay, so somebody is having a doubt why order is from smallest. I'm assuming that you are willing to ask me that why did I place this 8 for the smallest element, then 7 to the 2 element. I don't think I should answer this. Okay, since you have asked me, I'm just answering it right now. But I believe that this is doable if you try to think about it. Since you want this guy plus Q to be the largest, this guy plus Q to be the largest, this guy plus Q to be larger than the neighbors. You want them to be greater than their neighbors. So don't you think that this one needs the maximum help right now? This one needs the maximum help. This 2 needs the maximum help after this guy. And this 8, which is the largest guy among these 3, does not really need any help, does not need any help more than these. So once these people are done, then he can get the value, any value. And you want these people who are the neighbors for your target elements, like this, and this. These are the neighbors. You want these people to have as small values as possible. So you would like to give them the smallest possible values from your side. And again, you will not make a terrible decision of giving a very big value to this 7, which is the largest guy among the ones whom you want to have the small values. Because if you give a big value to this 7, he will just screw us. है ना? He will just help, like he will just make sure that we get screwed. If you give him maybe 7 in some case, then the 7 plus 7 will become a very huge value. So you would like to give him the smallest possible value. Okay, and why would we consider both the options? Like 5, 7, 6, 5, 7, 6, and 2, 1, 8. Okay, so somebody is asking that will we consider these both the combinations, like one of the possible combinations was this and the other possible combination was this? See, if when you consider one combination, it is if it is taking you something like big of n or n log n, है ना? Like the complexities are pretty small, the constraints are not so tight. You can just simply run the same thing for the other pair as well, because it will still have the same time complexity, and it will now make sure that the answer will definitely be correct. It is now bound to be correct, है ना? And the other thing is, if you just try to prove it, that when you are picking up the elements with the maximum guy, then you will always be able to get the maximum possible score. In that case, you don't really need to check up for the other, sorry, you don't need to check up for the other possible combination. Right now, I'm not gonna prove it completely. I will just give you some hints which I had in my mind when I was proving it during the contest. The thing is, in the worst case, the elements which you are willing to make the local maximas might have one. Hana, this is the worst thing which can happen with you. Like you are having one, and just the neighbor of this guy can be n minus 1. So you want this 1 plus qi here to be greater than this n minus 1 plus qi minus 1. Hana, you want this thing to happen, like this should be greater. So all you need to do is just put up an n here, which we are always doing. We are always giving the lowest element the biggest possible value which we can. And for this guy, since it would be the largest possible element in the whole array, because you are only picking up the alternating elements from for the biggest guy. So this is gonna be the biggest problem you can have, and it would be getting a +1 at the end. Like in the array Q, you would have got a +1 only here, whereas it is having a plus n. So this 1 plus n will actually be equal to like just n plus 1, obviously. And the other guy will be at most n. So in the worst case, you are still winning. And you can just try to think a bit more about it. And what I was having with this way of distribution is all of the values which I want to have as the local maxima are always greater than or equal to n plus 1. Because for the smallest element, I am giving it a plus n. For the second smallest value, I'm giving it a plus n minus 1. And even if the smallest values are actually 1, 2, 3, in that case, the values will come up to be n plus 1 in the AI array. Otherwise, if you are having 1 as the smallest value and 3 as the second smallest value among the ones which you are picking up, among these people which you are picking, then the sum will actually be even greater than n plus 1. So you know that your sum will always be greater than or equal to n plus 1. Whereas for the other people, for the neighbors, for the guy n minus 1, it would get only a plus 1. In the worst case, you will be basically for the largest element other than the ones which you are picking, it will get a plus 1 in the worst case. its neighbor, like the second largest guy, will actually get a +2. The largest can be only n-1, the second largest can be at most n-2, and so on. So the sum will be at most n, right? So this is how I proved it. Now it makes sense that if 8 is coming up among these elements, you will definitely pick up its pair. You could have skipped up this whole proof and you could have directly just said that I will create a function. First, I will check up for these elements with that function. Then I will just call that exact same function for these elements. You could have avoided the function at all like this. Sorry, you could have actually avoided the complete proof like this by just doing a complete search. Now the question is, what if in the array n is coming up here or here? If n is coming up either here or here at one of these places instead of coming up in the middle. So my initial intuition was that wherever I see n-1, I will just pick up that pair. That was my initial intuition. And it turned out to be incorrect. Let's consider a case like 4, not 4, but yeah, let's consider a case 6, 1, 4, 5, 3, 2. So among the middle guys, the fifth is the largest guy. So I was just picking up these two as the best people. But the problem was, if this one comes up to be as the neighbor of the largest guy, then like you know that this guy will have n+1 in the array A, and the Padosi will also have n+1 because in it is n in itself and it is getting a +1 at the very least. So in this case, you will not really have this condition. So it will fail at some places. But at the same time, if you see like the last case, in the proof of the last case, we did not really care about the largest guy among the ones which we are picking. We only cared about the largest guy which can cause trouble for us. So here in this case, when 6 is coming up here, if you just still, like even in this case, if you just pick up the elements which are alternating to this 6, the same proof which we discussed just now will actually work here as well. So now the approach is pretty simple. In the array P, like whatever array P you have, find out the largest element, like wherever it is. You can just find out whether it is coming up at the odd index or at even index. If it is coming up at the odd index, like right now, if you're having one based indexing, then it is coming up at odd index. Then just go to all the other odd indices and try to make them the local maximas, and that's it. So guys, does it make sense? Please say yes or no in the chat. Should we move on to the code, or do you have any doubts? And if you have any doubt, then please ask about the doubt. For the proof, you will have to put up efforts by yourself after the session. If I just like I gave some good idea about the proof, I believe that it would be doable from here on. And yeah, by the way, you should check out the editorial here as well, like for this problem also, because they might have some very good proofs. Generally, the text editorial are supposed to give concrete proofs. Anything else? So let's move on to the code then. First of all, I took all the inputs, after which this is unnecessary. Initially, I had written incorrect code and then I just did not write it completely once again. Here, all you need to do is just figure out, like find out wherever the value n is coming up in the permutation and just note its parity, whether it is even or odd. And the next thing I did is just put up all the elements inside two sets, or you can use priority queues if you want. Just store all the locations wherever you have been storing these. Sorry, yeah, just store all the indices of these elements in the priority queue or multiset, so that you will have these elements coming up in the ascending order along with their indices. And I'm just assigning them, like in the answer array or the array queue, I'm just assigning the values from larger to smaller one by one. And this is the edge case. This edge case is actually saying that, you see, where it is. Yeah, we talked about a case that if you are picking up, like if you are willing to have these three as the local maximas, then you would like to place the largest three elements here. After that, for the fourth element, instead of placing them among any of these, you would like to place them here. So place it there so that it is wasted. Even if you don't do this, the code will still work. So uh, the code could have been written shorter. I did not really need to write it as an edge case, but it's okay. After that, I'm taking the other elements, which for which I wanted their values to be smaller. And then this is just a for loop for checking whether my solution is correct or not. Like I'm just writing up a small checker function so that in case if my solution fails somewhere, and the reason it is failing is one of these things, basically it means that my implementation is not really working as it should have worked according to my logic. Like it's not working as my logic. In that case, it will just give me a runtime error so that it will be easy for me to debug. It will be easy for me to understand that where is my code, why is my code not working. Um, and then I'm just printing the answer. So, guys, does it make sense? Is the problem 3 clear? Say something like yes or no. Shall we move on? Okay, great. So now this is the fourth problem. During the contest, I messed up at the fourth problem. So I could not submit it. Since I have not submitted it, I'm not really 100% sure about the approach. That's why I did check out someone else's solution, and I will tell you about someone else's solution in brief. So the explanation will not be very descriptive. First of all, let's see what the problem is. This is an interactive problem in which there is an hidden array of length n, and we have to like we will be given one integer k as well, and we have been told that for any subarray from L to R, f L comma R, the value of L f of L comma R will be equal to the maximum element in this range, like mx is the maximum element of this range, multiplied with R minus L plus 1, which is nothing but the number of elements in this range. So this is f of L plus f of L comma R. And in the interactive problem, we have not been given the array. We are only being told about the n comma L, so n comma k variables. And like what we can do is we can ask queries. In every query, you will give L and X as the inputs for the query, and the computer will return you the smallest possible value R, for which f of L comma X, this thing will be sorry, f of L comma R will be equal to X. It will return you the smallest such R. And what we have to do is we have to tell like let's say if we partition the array into k subparts into k pieces, here k is equal to 5, let's say, then in that case for the first subarray, maybe if you say these points are c1, c2, c3 and c4, then you want f of 1 comma c1 to be equal to f of c1 plus 1 comma c2 being equal to n, like so on till f of c4 plus 1 comma n. You want something like this. So basically for each and every subarray, the score of that subarray should be equal to each other. And let's say if it is equal to m, you have to print the maximum possible value m in the array. So this is the problem. And like it was a pretty tricky one. The problem was a bit tricky. The thing which you had to observe here was the maximum possible value of m here will be a multiple of m, multiple of mx. Will be a multiple of mx, where mx is the maximum element in the complete array. Let's say if you're having an array like 136121, 136121, if you're having this kind of an array, the maximum element is 6 here. So the maximum value of m, like in any subarray, wherever this guy comes, since you want to have this element coming up in exactly one subarray, wherever it comes, the value f of l comma r, whichever subarray contains it, would be a multiple of l. No, sorry, would be multiple of a 6. Actually, will be, not would, will be a multiple of 6. है ना? Similarly, it will be a multiple of all the other elements as well. No, sorry, my bad. There is no constraint on it being a multiple of all the other elements. If there was a 5 there, there is, like in this case it will happen, but there is no mandatory constraint that if 5 occurs in the array, then the final answer will be a multiple of 5, because 5 might come up in a subarray where 5 is not the maximum element and it has no contribution in the value of m. But for the maximum element, like the maximum element of the array will definitely be the maximum element of some subarray. Like in any subarray it comes, it will be the maximum element. So f of l comma r will definitely be a multiple of mx, right? Whichever is the maximum element in the array. So for the value m, you only have few possible options, because like it should be a multiple of mx. And there is one more thing. Like if you try to figure out what will be the max, if you since okay, one more thing. Finding the maximum element of the array is not a hard task, because f of, like when you give l and x as the inputs and it returns you the smallest r such that this equation is satisfied, and you know that the LHS is nothing but mx into r minus l plus 1, it is coming up to be equal to x. So whenever you make a query and if you get some r which is in case if no r exists, then r will be equal to n plus 1. But in the other cases, when you get some actual value of r, then you know about this variable, you know about this variable, you know about this variable. So you are actually getting to know about the maximum element in that range. है ना? You are actually getting to know about the maximum element in the range from L to R whenever you get some value of R. So what you can do is, like for the complete array here, f of L comma R will be nothing but n into mx. The size of the subarray here is actually equal to the complete array when you're talking about the complete array. So it will be equal to n into mx, the maximum element in the array, right? So if you just raise up queries like n into n into n minus 1, n into n minus 2, and so on, at some places you will get r equal to n plus 1 as the response. Like you might get a response like n plus 1 here, n plus 1 here, n plus 1 here. But at some place you will definitely get the answer like the reply as n. Wherever, like at any point, whenever you get the second element equal to mx, the response will come up to be n. है ना? Right. Like these are actually the values of x which I have been saying here. So you will be giving L equal to 1 every time and x being one of these elements going in the loop. So at some point of time, you will get the value of mx. Now, once you have got the value of mx, you already have some idea for m. है ना? We can approach now. This part is something I think was intuitive. Like I was able to see this idea for getting the maximum element. That if I ever have to find out the maximum element for any subarray, then I can just take up, like if I have to figure out for any arbitrary subarray, not just the complete array, L is the starting point, then I can have queries like, and if R is the ending point for which I want to find out the maximum element, then I can just say L comma R minus L plus 1 into some element maybe I. And whenever this thing, like when I raise up this thing and the response comes up to be R, I know that this I must be equal to the maximum element. So this is what you could have thought of. Like I expect that if you're coming up to solve the D problem, then maybe you could not think about this on your own during the contest, but it should be understandable at this point. Now, after this, what can be the what can be the possible values of m? Let's say that these are equal to mx, like 2 into mx, 3 into mx, and so on. But till when? Like if you are thinking about checking for each and every value of mx, then till when do you need to go? So you will have this doubt. Someone might have an idea that since the uh, like in the worst case, what can happen is all the values of the array are equal to mx, right? So since you have n elements, and out of these n elements, there will be k partitions. So like since there will be k partitions from n elements, n by k is the number of elements you would have in all the subarrays. है ना? In the worst case, when all the values of the uh, array are actually mx, or most of the elements are equal to mx, in those cases, like the maximum possible value of m will be somewhere around n by k into mx. So what you need to do is you can just, like if you have fixed, like you already have fixed k, n and k are already fixed, and you can find out mx in n queries. In this interactive problem, we had a limit of 2 n queries, out of which we can use n queries to figure out the value of mx. Now we know that we have only n by k possible choices for this mx, from mx, 2mx, 3mx till n by k mx. So now we just have to think about a function, let's say a function g, or maybe just let's call it a function as check. a function check which will take this value as input, maybe let's call it as m for now, and it will return true or false. It will return true or false that whether it is possible to have m as the solution or not. So you already know that you want k partitions now, and like you already know that you want m to be the result of this, like f of 1 comma c1 should be equal to m. You don't know about this value of c1, but you know about the value of m, you know about the starting value of l. So you can just write up a query 1 comma m, like this is l and this is x for us for now. For the query, it will return you some response r. For now, let's call it as c1. This is the response. So the first thing is c1 should not be equal to n plus 1, right? First of all, c1 should not be equal to n plus 1. Now, if it is equal to some value less than n plus 1, then you know that you have got your first partition from 1 to c1. Now check up for the next partition from c1 plus 1 till c2. So now for the next query, you have from c1 plus 1 till c2. And again, the result should be m. So now you will raise up a query, that is query of c1 plus 1 till like yeah, the value of x here is m and the value of l here is c1 plus 1, and you will do this thing k times. When you do this thing for the kth time, what you want is the last response you get, let's call it as ck, should actually be equal to n, because the whole array should have been covered. You want that the whole array should be partitioned in exactly k elements, sorry, k partitions. So the last response you get should be equal to n, and obviously at any place ck, like ci should never be equal to n plus 1. So this thing should never happen, and this thing should happen at the end. So for checking for k partitions, like you will have at most k queries being used for each and every one of these values, at most k queries, and since these are n by k uh, possibilities in themselves, and you're having at most k queries every time, so it will come up to be n. We have already used n queries and we are having at most n queries now. So in total, we are having at most 2 n queries. So this thing should work. Now the tricky part, which I felt during like for this problem, which I could not think of during the contest, was observe this, that for a particular for a particular value of mx, which is going to be constant since the array has already been generated when we are getting the inputs. So this value of mx, which we can get very easily in n iterations, n queries, for that there will be only n by k possible choices. So I missed this part. If I had observed this part, then I might have been able to think that for a particular mx, like I can just check the answer for each and every mx. And for checking for each and every mx, it is a very simple thing. You just have to raise up the queries again and again and get the value c1, c2, c till cn, and cn should be equal to n. Sorry, ck. So that's it. The number of queries are not going too much. And talking about the time complexity, this is something I was having in my mind as soon as I saw this part, that n will be less than equal to 1, like 10 raised to the power 4, and the time limit is 3 seconds. So anything like n square will easily pass. Big O of n square will easily pass. And I think that this is what will happen here. In the case when, let's see, the where it is. Yeah, you're having n by k possibilities, possible choices. And for each and every one of them, you are having big O of k time complexity. So the time complexity is going on to be big O of n by k into big O of k It is coming up to be big of n, I think. I think I'm missing out something right now. Like during the contest, when I was thinking about the time complexity, it was coming up to be big of n square. Maybe like no, sorry, this was my time complexity. Let me see it again. So the very first step which we have been doing is figure out the maximum element. It can be done in big of n time complexity, right? We will just iterate over a loop from x equal to, or maybe just say I equal to n to I greater than equal to 1. So it will be big of n time. After that, we have got n by k possible choices, right? We have got n by k possible choices for the target. And then for checking for the target, we are just raising k queries. So it is big of n by k into k. And it is coming up to big of n here and big of n here. So yeah, maybe the time complexity might be big of n. Just in case if like I would suggest that you should also just check it out once. Uh, right now, I might be missing out something. Because if big of n solution is possible, then the chances of them giving this kind of constraints are quite small. Like they could have just created two problems, D1 and D2. है ना? If there is a small brute force solution as well. Okay, so that's it for this problem. I have not submitted it for obvious reasons, like my solution did not work during the contest, and after the contest I realized that I was having some uh, incorrect assumption during the contest, due to which my solution did not work out. So thank you for watching the video, and please give your feedbacks in the comment section. It will help me to improve. Whether it is good or bad, I will be happy with both of those feedbacks, both kind of feedbacks. Thank you.